If you've ever carried a USB flash drive in your pocket or used one to transfer files between computers, you know just how convenient these small devices can be. They've become an everyday essential, whether for students saving projects, professionals transferring presentations, or just regular people keeping photos and videos safe. But here's the thing. Very few people ever pause to wonder about it. How exactly are these compact devices brought into existence? What really happens behind the scenes to transform raw materials into something capable of holding gigabytes, or even terabytes, of information inside a case no larger than your thumb? The truth is, the making of a USB flash drive is nothing short of remarkable. It's a process that merges advanced microelectronics, precision engineering, and the efficiency of modern large-scale assembly lines. What may appear on the outside as just a simple plastic stick is, in reality, the end result of a complex sequence of steps involving silicon wafers, printed circuit boards, microcontrollers, and memory chips, all tied together by meticulous quality checks to ensure reliability. Every detail from the microscopic circuits etched into silicon to the design of the outer shell plays a role in making the device work seamlessly. And today, I'm going to take you on a journey deep inside a storage device factory, where you'll get to see how these tiny but powerful tools are born, step by step, and why they remain one of the most important inventions of the digital age. The journey begins with the very core of every USB flash drive, the memory chip. This tiny yet powerful component is the true heart of the device, the place where every photo, document, song, or video you save actually lives. At its foundation, the chip is built from silicon wafers, which are created in highly advanced semiconductor facilities. These wafers aren't made in ordinary factories. They're crafted inside ultra-controlled clean rooms, where even a single speck of dust could destroy an entire batch. In fact, the air inside these clean rooms is filtered thousands of times per hour to maintain near-sterile conditions, because the circuits etched onto the wafers are so small that even microscopic contaminants can ruin them. Each wafer is carefully prepared to hold dozens, sometimes hundreds, of integrated circuits so tiny that they're invisible to the naked eye. And yet, each of these circuits has the extraordinary ability to store information as electrical charges, forming the digital backbone of the flash drive. To create the wafer, purified silicon is melted at extremely high temperatures and then cooled in a way that allows it to form a perfect cylindrical crystal known as an ingot. That ingot is sliced into thin wafers, polished until they're flawless, and then sent into photolithography chambers, where ultraviolet light is used to etch microscopic patterns onto them. Layers of conductive and insulating materials are deposited and etched away, creating billions of tiny transistors that will eventually make up the flash memory cells. Once the wafers are complete, they are cut into small squares known as dies. Each die is then packaged into a protective case to form what we call NE-and flash memory chips. These are the building blocks of every USB flash drive. Alongside the memory chip, another critical component is the controller chip. Think of the controller as the brain of the USB drive. Without it, the memory chip would just be a lump of silicon. The controller manages how data is written, read, and erased, but its role goes far beyond just shuffling information back and forth. Think of it as the brain of the USB flash drive, silently orchestrating every task so the device seems effortless when you plug it in. It decides exactly where each bit of information should be placed inside the memory cells, almost like a librarian carefully storing books in different sections so nothing gets lost. It also keeps constant watch over the integrity of your data, running background checks to make sure files don't become corrupted over time. One of its most important jobs is something called wear leveling, a process that spreads out how often different parts of the chip are used. Without this, certain cells would be overworked and eventually fail much faster, shortening the lifespan of the drive. Thanks to the controller's invisible oversight, your flash drive can endure thousands of cycles of writing, erasing, and rewriting while keeping your files safe and accessible. With the essential chips ready, the next stage of the process is assembling them onto a printed circuit board, or PCB. The PCB is like the skeleton that holds everything together. It's a thin, flat board made of fiberglass or resin with copper pathways etched across it. These copper lines act like roads for electrical signals, connecting the memory chip, the controller, and the USB connector. In the factory, automated machines called pick-and-place robots position the chips and other small components with stunning accuracy, down to fractions of a millimeter. Solder paste is applied to the board first, and then the components are carefully placed onto it. After placement, the entire board goes through a reflow oven, where the solder paste melts and solidifies, permanently attaching the components. Now, the USB connector itself needs to be added. This is the metallic part you plug into your laptop or desktop. It's usually made of steel or nickel-plated brass for durability and conductivity. On the assembly line, the connector is fitted onto the PCB and soldered in place. Together with the chips, this forms the functional core of the flash drive. At this point, it doesn't look like much, just a bare circuit board with some chips and a metal connector. But this tiny skeleton is already capable of storing and transferring data. Before the casing is attached, the assembled boards undergo initial testing. Specialized machines plug in dozens of these boards at once and run diagnostic programs to check whether the memory and controller are communicating properly. They write and read test data, measure transfer speeds, and verify that the device can handle different types of files. Faulty boards are immediately rejected or sent for repair, while the functional ones move on to the next stage. The casing of the USB flash drive is where most of the visible design comes in. Depending on the brand, this casing could be made of plastic, metal, or even wood for novelty designs. The casing not only gives the device its final look, but also protects the delicate internal components from dust, moisture, and accidental damage. Plastic casings are made using injection molding, where molten plastic is injected into molds shaped like the outer body of the USB drive. Once cooled and hardened, these casings are ejected, polished, and sometimes printed with logos or labels. Metal casings, on the other hand, are cut and shaped using stamping machines, and then polished to achieve a smooth or brushed finish. The core PCB is carefully placed into its protective casing, making sure it fits securely within the mold. Once in position, the two halves of the outer shell are either snapped tightly together or bonded with industrial-grade adhesive, depending on the design. This step not only finalizes the structure of the flash drive, but also ensures that the delicate circuitry inside remains protected from physical damage. At this stage, manufacturers may also integrate extra features that add both function and appeal, like swivel covers that rotate to shield the connector, sliding mechanisms that allow the connector to retract inside the body, or small loops that let you attach the drive to a keychain for portability. For models intended to withstand tougher conditions, additional layers of protection are applied. These can include silicone seals that keep out dust and moisture, or rugged rubberized coatings that cushion the device against drops and impacts. Every adjustment here turns a simple circuit board into a reliable, everyday tool that people trust to store their most valuable data. With the casing complete, the USB flash drive is essentially finished. But the story doesn't end there. Each drive must go through a series of quality control checks before being packaged and shipped. Quality control involves both physical inspections and electronic tests. Drives are checked to make sure the connectors are firmly attached, the casing isn't damaged, and the branding is correctly printed. Electronic tests verify that the advertised storage capacity is accurate and that no memory errors exist. Some factories even conduct stress tests, repeatedly plugging and unplugging the drives thousands of times to simulate years of usage. Once the drives pass all tests, they are loaded with firmware that allows them to interact with computers. Firmware installation is usually automated, with racks of drives being connected to programming stations. After this step, they are formatted and sometimes pre-loaded with promotional content, software, or security features, depending on the brand's strategy. Finally, the drives are packaged. Packaging can vary widely. Some come in simple cardboard sleeves, others in plastic blister packs, and high-end models may even come in custom-designed boxes. Packaging lines are equipped with automatic labeling machines that print barcodes, product information, and serial numbers onto each box. From here, the finished USB flash drives are boxed in bulk and shipped out to distributors and retailers across the world. Now, while this explains the technical process, it's also worth reflecting on just how remarkable the journey of a USB flash drive really is. What looks like a cheap, everyday gadget is the product of advanced semiconductor technology, global supply chains, and high-precision machinery. Each time you plug one in, you're relying on billions of microscopic transistors etched into silicon, working in harmony to hold your memories, your work, or your entertainment. Behind its simplicity lies an incredible story of science and engineering. Think about it this way. The very first USB drives introduced around the year 2000 had storage capacities of just 8 megabytes. That's not even enough to hold a single high-resolution photo today. Fast forward to now, and we have flash drives capable of holding several terabytes of data. That's thousands of hours of video, millions of documents, or decades of music. And the devices themselves haven't grown much larger. They've just gotten smarter, more efficient, and more affordable. What's even more fascinating is how these drives are evolving. Factories are constantly working on pushing the limits of flash memory, making chips smaller but denser, faster but more durable. Some flash drives now come with biometric security, allowing you to unlock your files with a fingerprint. Others are designed to connect wirelessly, bridging the gap between traditional storage and cloud computing. The story of the USB drive is still being written, and the factories making them today are preparing for a future where we may carry even more powerful storage devices in our pockets. And here's where the bigger lesson really comes into focus. Every piece of technology we rely on has an unseen story behind it, a hidden world of design, engineering, and painstaking production. From the simplest USB flash drive to the most advanced smartphone, none of these devices simply appear. They are the result of years of innovation, countless prototypes, and millions of tiny, precise steps that all add up to the convenience we now take for granted. When you plug in a flash drive, you're not just using a storage tool, you're holding the outcome of human creativity, collaboration, and problem solving. The next time one rests in your hand, maybe you'll pause for a moment and see it differently. Not just as a piece of plastic and silicon, but as a small, everyday symbol of human ingenuity at its absolute finest. So, the next time you save a presentation, transfer family photos, or back up important files on a USB flash drive, remember the journey it took to get into your hands. From silicon wafers etched with microscopic precision to circuit boards soldered by robots, from plastic molded under high pressure to endless quality checks, that little device carries a legacy of technological progress and manufacturing brilliance. And here's my call to action for you. Don't just use technology, understand it. The more you learn about how things are made, the more you appreciate their value. And if this deep dive into the making of USB flash drives fascinated you, stick around for more, because the world is full of everyday objects with extraordinary backstories. Subscribe, share this with someone who'd find it interesting, and let's keep uncovering the hidden stories behind the tools we use every day.